Yeah, welcome everyone to this lecture uh, on this course of Mathematics 1. So in this lecture, I will talk about the multivariate calculus. Okay, so multivariate calculus will start with the basic term, that is the calculus. Okay, so there are, if you see in the name itself. Okay, so there are two words are there I can see. So one is that your multivariate, another is calculus, right? Now in the calculus part, you already know that calculus, you already have seen that in the calculus what is the limit and what is continuity and what is differentiation and integration, right? Now in the other part, that is in the multivariable, if I break this term multivariable, then I can see that multi, another is variable. Okay, so multiple is the multiple and the variate means the variable. Okay, so other way it is also called multiple variables. Okay, instead of multivariate it's called the multivariable. So both name are the same. Okay, so in the calculus you have only the single variable. So what I mean that, suppose there is for the single variable you have only one independent. This is the independent variable, right? So basically we call that y equal to fx, right? So y equal to fx equal to x square. So this is the equation of the parabola, uh, where x is our one independent variable. So this is the single variable. Now instead of this uh, one independent variable, only single independent variable, in the case of multiple variable function, we have more than one independent variable. So in this function here, f of xy equal to x square plus y square, we have two independent variables, x and y. If I call this function as z equal to f of xy, and that function is defined as x square plus y square, then here x and y are the two independent variables. Okay, so it is a one example of uh, multivariable function. So in this course we will learn what is the limit, continuity, differentiation regarding to this multivariable function. That you already know that limit, continuity and differentiation in the case of um, single variable case. Now for this multivariable, what will be its limit and how we can define the continuity of this function, and about the differentiation, what is the differentiation of this function, we will talk about in this lecture. Now uh, if I plot this graph y equal to fx equal to x square, so it will be looks like this one sort of parabola. Now what will look like if I plot this graph z equal to fxy equal to x square plus y square? Now if I plot, so it will be one sort of surface. Okay, so here this basically uh, representation of this equation z equal to x square plus y square. Now here these different surfaces of this plot. Now if I move, so if I see that in this direction we have your x-axis, in that two horizontal things, that is the x-axis, and y-axis, that is the plane. And if I see the vertical axis, so here z, that is basically your vertical axis. Yeah, right. So this is your dependent variable. So x and y, that is the two independent variable, that is in the plane, if I see, and z is the dependent variable. And this is the equation of the curve, and this is basically surface of this curve, if I see that in the 3D diagram, right? Now in this lecture basically we talked about the limit, continuity and differentiation of this sort of function. So here we have two independent variable, we can have more than two independent variable. Okay, so mostly we will talk about the two independent variable. Now let us see uh, some example where why this multivariable will be useful. So if you see this function, the area of the triangle, that you know that is base into height. Now if you write the area of the triangle as a, and base and height, that is basically two independent variable, so area will be function of two independent variable, base and height. So this is also one example of multivariable function. Now another one is that volume equal to pressure into temperature. So volume is also is a function of pressure and temperature. If I write in the terms of function, so V, that is denoting volume, and that is a function G equal to P of P and T, right? So P and T are two independent variable and P is the dependent variable. So this is one example of multivariable function. Now another one, that is the volume of the, let's say, rectangular box. So it has three dimensions like length, breadth, and the height. And if you multiply these three terms, then you will get the volume. So volume here of the rectangular box is a function of three independent variables: L, B, and H, right? So in this purpose, in this sort of problem, so there will be many sort of problem where you can use the concept of multivariable uh, calculus things in this area. Okay, so thank you. See you in the next lecture.